Do we still have George in the room? Hi.
Hello.
All right. So our first question is a bit of a doozy. Let's read this one. I'd say you could work very specifically about or with streamers. Yes, I know there's not many on Linux, but still, and gamers in general. For me, it's been a pain to create loopback syncs and to grab audio from specific app streams. For live casting, a play session to YouTube or Twitch, or open alternatives. In question form, have you thought about the streaming use cases?
Well, yes, creating this loopback sync, actually, in Pulsar, to grab audio from a certain application, you need to create a loopback sync. In Pipewire, this should be easier because you can grab audio directly from the application. The caveat there is that you may not be able to do it with standard Pulse audio tools like Pavu Control, that they don't fully understand how the routing is done. But if you use a Jack graph tool directly, you can link application to any other application stream, and therefore you can more easily grab audio from an application. So yeah, I think Pipewire should make this use case easier.
Oops. Okay, let's go to the next question. Have you reached out to Blackmagic? They'd probably have the best or worst test suite for you.
No, I haven't reached Blackmagic. I'm not even sure what they are and they offer. So.
Okay. Now it looks like the last one in here, there's one more being typed out, but there is a comment that says other media creators, podcasters come to mind with creative Jack setups could lend a hand. Again, that was only a comment, not a question. And one last question that just popped up. Do you see Pipewire replacing GStreamer for things like recording from a webcam and such?
The answer to that is no. Pipewire and GStreamer are two very different things. Pipewire is a system daemon that is there to enable multimedia content between applications, while GStreamer is a full multimedia library that enables creating multimedia applications. It has network streaming support and many other things that are not in Pipewire. Pipewire is merely transporting audio or video from one place to other in your system.
Okay, well, thank you for answering those questions. It looks like that's all that there was. Yeah, thank you for telling us about Pipewire, and I hope you get to enjoy the rest of the conference along with us.
Bye-bye.
Bye, thank you. Okay, everyone, we are going to take a short break and return in approximately 10 minutes for the next talk.
Hello everyone. Now it's time for Matthias Klassen and the Modelbased talk. GTK4 is almost here.
Yeah, hello, good morning. It's actually just going to be me. Emmanuel is instead giving a talk at GNOME Asia, so today it's just me. And I'll be talking about GTK4. Before I start, I want to say that I've given a similar talk at GUADEC a few months ago, and if you've been at that talk, the first half of my presentation will be fairly familiar to you, but if you hang on, the demo section will be all new and fun. So stay tuned for that. Yes, we've been working on GTK4 for quite a while now. Looking back, when preparing for this talk, I noticed that we did the 3.89.1 release, which was the first in our 4.0 development. That happened in November 2016, so it was actually 4 years ago. And since then, we've racked up almost 18,000 commits. But now GTK4 is basically almost here. We are up to 3.99.4, and we will do the 4.0 release within the next, I guess, 2 or 3 weeks. And it's time to take a look at what we have to offer. There have been a few brave early adopters during our 4 years of unstable development who have done test ports of various applications. For example, there was a Nautilus port around our 3.96 release. And later on, Georges ported GNOME To Do to 3.98. And we were very lucky to observe him trying to use our new drag and drop API. And thanks to that, our drag and drop API ended up looking a bit different than we thought initially. And it's much better. And since we've started doing our 3.99 releases, more people have taken a look and given us valuable feedback. And GTK4 will be much better due to all of you, everybody who took a look at what we had while it was still unstable deserves a big thank you. And yeah, what I will do in this presentation is to highlight some of the things that are new in GTK4 and that maybe were not possible to do in GTK3. But before I do that, I wanted to take a moment and look at the principles that have been guiding our development and the changes we've done, so you have some idea of why things have changed in the way they have. And let's see if this works. Yes. So one of the general principles, general direction of our API changes has been to emphasize delegation over subclassing. If you want, you could call this lessons learned from clutter. One of the motivations for this is to make writing your own custom widgets easier and less error prone. And as a consequence of this direction, you will see a lot more auxiliary objects in our APIs that take over certain aspects of functionality from the core widget classes. Another consequence is that many of our widgets are now final, so you cannot derive from them anymore. Instead, we expect that you will derive directly from widget, which has become a lot easier than it was in GTK3. Another general trend is that everything is a widget. That has already started in GTK3 many years ago. We first started with introducing CSS nodes, and then we introduced gadgets as another way of breaking up widgets into their components. And now in GTK4, we have completed this transition. And for example, if you look at a GTK scale, the trough and the slider of a scale are fully formed sub-widgets which maintain their own style and their own state, and they can receive input like any other widget. A big loser in the GTK4 transition is the GTK container base class. It has become much less important. Any widget can have child widgets now, and child properties, which is something that GTK container used to provide, have been replaced by layout children and their properties. And all the focus handling has been moved from GTK container to GTK widget. So when we were done with all of these changes, GTK container did really have no functionality left. So in fact, we just removed the class altogether. Yeah, another big loser in these changes is GTK window. In GTK 3, all the pop-ups, such as entry completions, menus, tooltips, and things like that, they were all using a GTK window underneath. And in GTK 4, most of them have been converted to use popovers, or at least a pop-up surface. And the popover implementation itself has been untangled from GTK window and made its own freestanding widget. And in addition, many pieces of functionality that are specific to top-level windows, such as handling of sizes and handling of window decorations, have been moved out into separate interfaces, such as GTK root or GTK native, or into their own widgets like GTK window handle or GTK window controls. On the GDK level, we've moved from modeling our abstractions on X11 concepts to following Wayland. As a consequence, we now have surfaces instead of windows, and things like screens or visuals or explicit grabs are all gone from the API. And we're also moving away from the complex hierarchy of input devices that X input has, and have a much simpler setup for devices. This should not affect applications too much, but it does affect GDK backends, and it in fact should make it a lot more straightforward to write GDK backends. And as a sign of things to come in that area, we do have a new backend for OS X, which still needs some love and nurturing, but it does look like a promising start. Right, moving on from the principles to surprises. With every big change, and the change from GTK 3 to GTK 4 is certainly very big, there are some surprises and unexpected changes that you did not anticipate, and that might hold you up much longer than they should when you ported an application from GTK 3 to GTK 4. So I figured it would be a good idea to point some of these out up front so you are prepared. And the first surprise is that widgets are visible by default now. This is one of a number of API changes where we've just changed defaults that were wrong before to the expected value. If you create a new widget, you typically want it to be visible, so it makes a lot of sense to have the visible property defaulting to true. But if one of your UI files inexplicably looks different in GTK 4 than it used to be in GTK 3, then you may want to check if it contains any widgets that were never visible in GTK 3 because you just forgot to set visible to true. And in GTK 4, all of those will just show up. Surprise number 2 is that GTK container is gone. I already mentioned that. This can require some work if you are creating your UIs manually. There's a certain style of UI creation code where you always call GTK container add on boxes, windows, and similar containers. And all these calls have to be replaced by their respective non-generic counterparts. For example, GTK box now has a GTK box append function, and all the widgets which just have a single child widget, like GTK window or GTK frame, they have a set child API that replaces the generic container add function. That's admittedly a change that can be a little annoying to deal with. But the good news is if you're using GTK Builder for your UI, you are not affected by that at all, because the child element in UI files works just the same as before. GTK Builder UI files are affected by some other changes, for example, that child properties are being replaced by layout properties. But we have a tool called GTK4 Builder tool that can help you adapt to that. If you use the simplify command of GTK4 Builder tool and you pass the --3 to 4 option to this command, it'll try to rewrite a GTK3 UI file to the syntax expected in GTK4. That tool is not perfect, and you should always verify what it produces and pay attention to the warnings that it spits out. But during GTK4 development, we've run this over all the UI files in GTK several times, and it works reasonably well. So that's definitely something you should keep in mind if you have a GTK3 application that needs porting. All right, with that, I'll change gears a little bit and try to share my screen. I hope that works, and I will show some demos. Before I do that, I wanted to say that in my Grodek version of this talk, I showed minimal test cases as demos that were showing how you do layout, rendering, and input in GTK4, and I walked you through the code. If you're interested in that thing, you can find those demos on GitLab, or you can just watch the recording of that talk I gave. But since I gave that talk, we've worked pretty hard on adding nice examples to GTK demo. So today I want to just show some of those demos to give you an impression of what GTK4 can do that was not possible in GTK3. And with that, I'll try to share my screen. I hope this works. Okay, sorry for that strobe effect. I have no idea how to avoid that with big blue button, but I hope you can see the GDK demo window now. There's a lot of demos in this and a lot of new demos, so if you think you know what's in here, it's worth taking another look. As I said, we've worked pretty hard on producing some demos that are maybe a little more interesting. I want to start out by showing a few demos about layout managers. Layout managers are one of those auxiliary objects that I mentioned earlier that we've kind of inherited from Clutter. And every widget has a layout manager that basically is responsible for controlling how the child widgets are placed on screen. And here's a simple layout manager demo. It's basically a widget that has child widgets that are placed in a grid. The layout manager determines the positions of the child widgets. And they look just like color blobs, but they are actually widgets which have tooltips, as you can see here. And if I click my mouse button here, you can see that the layout changes and the child widgets get rearranged in a circle now. And I can actually undo that and do it again. So that's fun to play with. We don't have the full-grown animation framework in GTK4 yet, but simple transitions between layouts like this are very doable with just a tick callback, as this demo shows. So basically what the layout manager here does is it computes the position of the children in both these layouts, both for the grid and for the circle. And then we have a tick callback that interpolates between those two positions for each child. And if you have ever played with the Clutter demos, this may look familiar to you. This is a pretty direct translation of a Clutter layout manager demo that I did. And I think it does a good job of showing that it's pretty easy to position child widgets on a 2D canvas. But one of the things that are new in GTK4 is that we actually have a full 3D scene graph and 3D transformations between children. So after I did this, the translation of this Clutter demo, I thought I wanted to show off transformations that are a little less trivial than just what this demo showed. So I spent a weekend writing another layout manager demo with transformations. It's this one. Again, the ingredients are the same here. This is just a container which has a bunch of child widgets. In this case, they are icons. And all the magic is in the layout manager that computes how to place these child widgets into our theme graph. And in this case, it places them on the surface of a sphere. And I thought I'd make this demo a little more interesting by also adding keynav. So if I click the arrow keys here, you can move things around and see that actually reacts. So that is fun to play with. And yeah, maybe I can do a little interaction here. I'll bring up the GTK inspector because I wanted to quickly show you that these are actually widgets that are responsive to input, and it's not just a movie. And to show that, I can turn on a hover effect, and you can see that all of these widgets actually receive input as I move my mouse over the window. They get hovered. Right, maybe that's enough for layout managers, and I'll move on to the next big topic, which is another big thing that we added to GDK 4 is support for model-based list widgets. We eventually want these to replace GDK tree view and GDK combo box and so like. We're not quite there yet, but this is what we have. This is a column view that shows what our model-based list widgets can do. The model in this case contains the content of the Unicode character database, so that's roughly 33,000 items. And you can scroll around here and you can select things and you can explore this and find characters you never knew existed. So that's a fun thing to do. And as far as the widget is concerned, you can see that it does have functionality that you expect from a columned list. You can like resize the columns and you can reorder the columns. We also have support for sorting by column and for filtering that this demo does not show yet. So you could obviously do exactly the same demo with the tree view. The difference here is that we actually use widgets for all the content. So every cell in this grid is a label, and you can use the full power of GDK widgets to display your data. We don't create widgets for the whole model. We only create widgets for the visible range. And if you scroll around, we'll recycle the widgets. So that is all as you would expect. And you might say, well, 33,000 items, that is not very impressive in terms of model size, and you would be correct. So if you want to see a bit more impressive model sizes, we can switch to this example for a grid widget, which is also using a model, the same kind of model that the column list used, and we can switch the model size to 2 million items. So now we have a data model that contains 2 million colors, and we can still use this UI fairly comfortably. And one thing we can do here is we can actually sort this, and as you can see, the sorting happens in the background, and while it's going on, the UI stays responsive. And that's something that we worked pretty hard on and that we are kind of proud of. The same is true for filtering. You can also filter a list-based widget in the background, and the UI will stay responsive as the filtering is happening, although this demo doesn't show it. One other thing that this demo shows is that we have selection as well. So you can make a rubber band selection here, and then you can get the data that's behind the selection and do things with it, like compute the average color. Usually, if you make a big selection, you just end up with something that is either gray or brown. So maybe that's enough for list widgets. There's more to explore here. If you want to click around yourself, there's more demos highlighting various aspects. But I want to move on and talk a bit about painting. And there it is. Yes, traditionally in GDK, whenever we need content that can be drawn, be that an image loaded from a file or something drawn by code, we end up using GDK Pixbuff. In GDK 4, we've kind of moved away from GDK Pixbuff. We de-emphasized that and introduced a new interface called GDK Paintable. When you load an image file in GDK 4, you end up with a GDK texture object, which implements the paintable interface. And likewise, when you load a themed icon, you also end up with a paintable. Paintables can produce different images at different times, so we can also present animations and videos using this interface. One of the best things about GDK Paintable is that it's a very simple interface, so it's very easy to implement yourself. It's really just 2 or 3 functions. And so the first example I want to show here is actually a custom implementation of GDK Paintable that overlays an emblem on top of an existing paintable, and then you get something like this. In GDK 3, we used to have support for what we called emblemed icons in GDK theme, but that was a fairly limited thing, and we've got rid of it. And instead, we can now use paintables for this. And as you can see, since paintables can be animated, and we overlay an arbitrary paintable here, you can now have animated emblems, which is not something that would be easy to do in GTK3. The next example of a paintable is loading an SVG. And you might say, well, GDK Pixpuff could load SVG since forever, so why do we need this? The thing is, if you load an SVG file with GDK Pixpuff, you end up with a Pixpuff, which is just a fixed number of pixels. And if you then change your window size, you end up with pixelated content because we just scale up those pixels, which is a bit of a bummer considering that the S in SVG stands for scalable. So with a paintable wrapper around the librsvg handle object, we can finally do better. And as you can see, as I make this window bigger, we actually re-render the SVG at the right size, and we get sharp rendering at any size here. And all of this requires just 100 lines of code for a fairly trivial implementation of GDK Paintable. Right, I already mentioned that paintables can be animated, and that is very nice, as we saw in this emblem example. But if you want to show actual media content, such as a WebM file, you typically want some more control over things like the duration or the volume. And for that, we have a separate interface called GDK Media Stream that fills that role. And we have a GDK Video widget, which adds some of the expected controls in the UI. And I'll show this demo here, which is basically just a window wrapped around the GDK Video widget. And as you can see, there's typical media controls down here, a volume control, and a scale that shows you the position. And that can render simple animations, but it can also render movies that you might want to show. And at the core of this GDK Video widget is just the same machinery that we saw earlier. It's a GDK Picture widget displaying a paintable that is changing over time. Right, so maybe that's enough for paintables. And if you are still around, you're probably here because you wanted to see wobbly widgets. So let's finally go there. And yeah, I'll give a brief introduction here. So in GTK4, we use OpenGL for rendering our UI. And in practice, that means we are using shaders for rendering the elements of our UI, be that like shadows or gradients or whatever we need to put together widgets. And since not everybody may be familiar with OpenGL, I'll quickly say what shaders are. So shaders are small programs written in a language called GLSL that get compiled and uploaded to the GPU. They run on the GPU, and basically they get run in parallel for every pixel that you want to render. And they can do simple things like just interpolating between different colors, or they can do more complicated things. And since we're using shaders for all our UI elements for GDK itself, we figured it's also fairly easy for us to allow applications to use custom shaders. And so that's something we did within the last half year or so. And this demo shows that. It's a little ridiculous and overcrowded because we try to squeeze every possible way to use custom shaders in a UI into this one window. But let's walk through that one by one and see what we have here. Those colored blobs that you see in the background are rendered with a shader, so you can just use a shader as an animated background if you want. And then the content of the window is 4 stacks, which are using shaders for their custom shaders for their transition between the different pages in the stack. And I'll walk through those in a bit, but I first wanted to say that the two stacks here on the right show actually the widget they show currently. The current page is done with a shader as well. That's a GDK GL area showing an example taken from the Shader Toy website. And as you can see, as I move the mouse over these widgets, there's a wobbly widget effect that is also done with the shader on hover. But now I'll click here to actually change the page, and you can see that there's a swipe transition, or this is called a wind. This stack has something called radio. This one is doing a cross warp, and This is the kaleidoscope. And all of these effects are not something that we invented ourselves. There's a website that we found that has a bunch of these effects ready-made, and we just copied the shader code from there, and it basically just works. And all these 4 stacks contain the same child widgets, and the last one in each stack is the source code for the shader, which you can see here. And you can actually make a change here, and you can recompile the shader and then use it again, and you can see the effect has actually changed. Maybe I need to make this a little slower so you can see what's going on. So yeah, that's fun, and I'm sure people will come up with maybe some useful uses for this and a lot of silly uses, but the capability is there, and I'm sure you'll have fun exploring that. Yeah, I think that's maybe enough demos for now. There's of course a lot more here in GTK demo. You can see we have quite a few demos, and you can explore that yourself if you have a build of GTK 4. Did my web browser crash while I was demoing? Did you guys miss all the demos, or did you see a little bit of it? Okay, I'm sorry for that. I hope you got a little bit out of it, and I'll pretend that nothing happens, and I'll let me see if I can actually. Yeah, of course I'm not presenter now anymore, so I guess I'll have to be made presenter again so I can change the slides. Thank you. So I showed you all of this and most of this. And before I wrap it up, I wanted to take a brief moment to talk a bit about what our plans and ideas are for what we'll work on once we release GTK 4.0 next month. So I haven't mentioned accessibility yet in this presentation, but this has been a focus of the GTK team, in particular a focus of Emanuele for the past year. We had a hackfest with some members of the accessibility community in February in Brussels. That was back when conferences involved travel. And since then, we've replaced the aging accessibility code in GTK with a new implementation that cuts out several layers of intermediate code and brings us much closer to what web browsers and Qt do in this area nowadays. So that was a good step up. For GTK 4.0, the aim in this area is to just have a functional AT-SPI backend that can support using GTK4 applications with Orca, the screen reader. But the plans for after 4.0 include writing backends for other platforms, which is something that we've never had in GTK. Our accessibility was always Linux only. And with our new with the new code that we have in GTK4 now, it should be a lot easier to write backends for, say, OS X and maybe also on Windows. So that is something that will be a first for us. And we're also looking at modernizing the AT-SPI layer on Linux. So far we are using it as is, but it really still smells of Corba, and it would be nice to improve on that. Yeah, another item, that's one item actually that we had to drop from our GTK4 roadmap because accessibility was considered more important than an animation framework. But we have not given up on it, and we will get back to it once we have 4.0 done. Yes, UI designer. Everybody loves Glade, of course, but it is not quite up to par with what other platforms offer in terms of UI design tools. And what's worse, Glade does not currently work with GTK4 because there were a number of changes in the UI file format, and Glade has not kept up with that. We did introduce a constraint-based layout manager in GTK4, which is meant to facilitate writing a more modern UI designer, but we have not actually gotten around to doing that yet. Maybe somebody out there wants to beat us to it and show up with a new UI designer. We'd love for that to happen. Yes, this next item, replacing GTK tree view, is a bit of a placeholder for the incomplete cleanups and API modernization tasks that are left inside the GTK code base. We did add the new list and grid widgets that I demonstrated a while ago, and they are meant to eventually replace all the cell renderer-based widgets like the tree view and the combo box and the icon view. But we have not actually removed those widgets yet. One of the reasons for that is that we did not want to make porting from GTK3 harder than it already is. Dealing with all the other changes is enough work, and it's much better if you can first do a GTK4 port and then, as a second step, replace your main widget, be that a list or a grid, and replace that with a model-based widget. Another reason is that it's just a lot of work to replace all these. GTK combo box itself is a beast, GTK tree view itself is a beast, but the others like icon view and combo box also have a lot of features that we kind of need to replace before we can drop them. Yeah, the last item I've put on this list of ideas is that it's not just GTK itself that needs to take advantage of new things that we have to offer internally. There's also a list of other libraries that provide more specialized widgets, such as WebKit, VTE, or libgweather, to name just a few. And all those kind of need to be ported to GTK4. Thankfully, a lot of that porting is either done already or it's at least underway. And one of the libraries I wanted to mention here specifically is libhandy, which in recent years has served as a useful breeding ground for adaptive modern widgets on top of GTK3, while the GTK team was busy working on GTK4. So we are very thankful for the people working on libhandy that they've kept GTK3 alive and modern in that way. But now that we have GTK4, we kind of need to take a look at what the future holds for libhandy and similar libraries such as Elementaries, Granite. And yes, so currently this list is not really a roadmap. It's just a grab bag of ideas really, but we'll have and it's not exactly clear yet which of these we can do in GTK 4.x and which of these will have to wait for GTK 5. In fact, we'll have a planning meeting to discuss this topic very soon, probably next week or the week after. And I'm sure we'll write a blog post with any updates on that. And that is really what I had to present here today. I hope the demos I showed give you some idea of what's possible to do with GTK4 and make you maybe want to try it out and maybe look at porting some of your applications. And with that, I'll probably open it up for questions.
There is some questions.
I had difficulty hearing that, but I understand that you probably want me to look at the shared notes.
Yeah.
Okay, so let me go there. I'll just read the questions as I see them, and we'll try to give you answers.
All right.
First question: will GTK4 work on macOS 11.0.1 that got released today? Good question. I don't have a Mac myself, And as I mentioned earlier in the presentation, we're having a new macOS backend that is being worked on, which is not quite complete yet, but it's getting there. Christian Hergert is doing that work because he has a Mac at home and was interested in taking this up. I assume that once the backend is functional, it'll work on macOS 11.0.1, but I can't tell you that anybody has had an opportunity to verify that in practice yet. Next question. What conclusions from Greg's keynote talk would you bring to GTK? Yeah, I'm sorry to say I missed Greg's keynote. I really would have loved to see it, but I was preparing for my talk, so I can't really answer that. I'm sorry. I'll have to go back and watch the video of that before I can say something. Next question. Is Android finally supported for GTK 4? No, not as of today. What I said in one of the slides is that we've simplified our GDK backend interface quite a bit. So in theory, it should be easier now to write an Android backend than it was for GTK 3. But so far, nobody has started to look at that seriously. And if anybody's interested in that, I don't think the GDK team itself has the bandwidth to take that on. We are lucky that we have Christian Hergert working on a new OS X backend, but we don't really have enough people to produce more backends by ourselves. I mean, if anybody else wants to show up, we'd be very happy to help out and guide any efforts. Next question. Will theming change any in GTK 4? Not significantly. I think our CSS support in GTK 3 was already more or less at the same level than it is now in GTK 4. If anything, we've probably removed a few custom things that were not necessary anymore because we now support more of the standard CSS mechanisms for doing things. But basically, the theming is all the same. You have a CSS style sheet, and widgets have element names and can have style classes, and all that is unchanged from GTK 3. Next question. Who are GTK developers? Keen hobbyists, paid by Red Hat, something else? We have both. We have people who are paid by Red Hat and are paid to work on GTK, and we have some people who also work at Red Hat but work on GTK as their hobby, and we have people who do not work at Red Hat. For instance, Emanuele is employed by the GNOME Foundation as a developer to work on GTK and other things. And yes, so it's a small team of, I would say, between 5 and 10 people who regularly contribute to GTK, and a larger group of people who are filing issues and sometimes provide fixes as well. Next question. Is there a Vulkan backend? So yes, maybe I'll step back a little bit here to say there's two different things here. We have GDK has backends for different platforms. As I said earlier, we have an OS X backend that's essentially the windowing system part of GDK, that where we have one backend for each platform. There's a Windows backend, there's an X11 backend, there's a Wayland backend, and we have a backend called Broadway for rendering GDK UIs in a web browser. And that's the windowing part. And then there's a renderer, which is basically determines how we render. And I said we are using OpenGL now, so that's done by the GL renderer. And we do have a Vulkan renderer as well, which is somewhat less complete. So for 4.0, I think the GL renderer will be our primary best supported renderer. We do have a cairo renderer as well, which is the renderer that gets used as fallback when we don't have hardware acceleration available. Yes, but the Vulkan renderer is a little less mature maybe than the GL one, and part of the problem here is that we as GDK developers are not really experts in using any of these APIs. So we are not game developers who have extensive knowledge in how GL works or how Vulkan works. So we are kind of feeling our way into these APIs and do as best as we can. But Vulkan is not an easy API to handle in this fashion. So if anybody has experience using Vulkan, and doing Vulkan development, and helping out with the Vulkan backend would be very much appreciated. All right, next question. Could GTK4 demo be added to FlatHub as a Flatpak? I feel that would build hype and let developers get hands on it even easier. I think that's a great idea. We do actually ship, we do have Flatpak builds of our demo apps, both of GTK demo and of Widget Factory. They are available from gitlab.gnome.org, but putting them on FlatHub sounds like a great idea. We should look into that. Next question. What is the GTK4 MM status? I'll take that question a little more generally and talk about bindings in general. So there's a lot of bindings for GTK. That has always been one of our strengths. And the GTK team does not have the bandwidth to work on them ourselves. We can provide the introspection data, like the GUR file that all the G-object introspection-based bindings are using, and we try to keep those up to date and fix any binding API issues that people point out to us. But we don't really have the bandwidth to work on bindings ourselves. So I don't actually know if anybody is working on porting GTK MM to GTK4. So I can't really answer that. I do know that people are fixing up the PyG object bindings. There's some overrides in there that need adjustments for GTK4, and I think that's actively being worked on. And I think we hope to have working Python bindings at least for 4.0. Next question, GTK5. How long is GTK4 meant to last? So as I alluded to in my presentation, we will have a planning meeting with the core GTK team in the next week or two, where I guess this topic will be discussed. So I don't really have a firm answer on this yet. My own opinion on this is that we should probably aim for what we said when we started GTK4 work. We said we'll have GTK4 in 2 years, and it turned out that estimate was wrong. To nobody's surprise, we took twice as long. It has taken us 4 years now. I think that was probably a little bit too long in retrospect, and I would hope that we can do a GTK5 a little sooner, but it's an estimate, so you know how to take it. Next question, what's the future of Cairo? Good question. Maybe some of you saw that pop up on Hacker News this morning. I'm struggling to find somebody to do a Cairo release that we kind of need, because we want some of the bug fixes in the font rendering that are in Cairo master, but have not seen a release, even though they have been merged well more than a year ago. And currently still struggling to figure out who I can convince to upload a Cairo tarball. So Cairo development is not entirely dead. There's people who are committing things, but I'm really struggling to find a maintainer who can do an actual release, because as things stand, most Linux distributions still ship Cairo 1.16, which is almost 3 years older now, I think. And the latest development snapshot, 1.17.2, is also 1.5 years old now. So things are not looking too bright in Cairo, and we'll have to figure out what we can do there. It's more palatable now than it was in the past to use other rendering APIs with GTK. Our draw callback that we had in GTK3 was taking a Cairo context, so basically you were forced to use Cairo, and that is no longer the case in GTK4. We have a snapshot vfunc that replaces the draw vfunc in GTK3, and that does not take a Cairo context. It takes a thing called a GTK snapshot object, to which you add the render nodes that make up your scene graph. And if you want, you can create a Cairo render node, which will then give you a Cairo context to do Cairo drawing. But it's no longer a expected part of the snapshot API. So in principle, we are slowly reducing our dependency on Cairo, but it's certainly still very common to render things using Cairo in GTK applications. So we still need that Cairo release. Next question. Is it possible to develop GTK using other languages like Rust or Go? I think there's two answers to that. The first one, the first question here is it possible to write applications, GTK applications in other languages? And for that, the answer is a very definitive yes. We have, as I said, a lot of bindings, and in particular, there's Rust bindings being actively developed currently, and there's bindings for many other languages on the GTK website. And as those bindings get adapted to GTK4, you'll be able to write GTK4 applications in any of those languages. As to whether you can develop GTK itself using other languages, for that the answer currently is we stick to C, because that's the universal language that makes binding to any other language relatively easy. Now, whether we in the future want to consider allowing Rust code in the GTK code base as long as it has a C API exported, that is to be seen. I'm sure that people would be interested in doing that. I think that's maybe all the questions I've seen here. There's no others, and I think
that does seem to be all the questions.
Okay, in that case,
thank you
all
very
for
much
your
for your presentation and answering those questions in such great depth. We appreciate it very much. We hope you also get to enjoy the rest of the conference along with us. So hopefully we get to see you stick around.
Sure, thanks.
Yeah, absolutely. Have a wonderful rest of your day or evening, wherever you are. And for our lovely audience, we will be right back in a few minutes with Alish from KDE, who will talk to us about Wayland. Hello, Alish. How are you? Still muted.
Yeah, I'm great. How are you, Alison?
Doing great. It's good to see you. Everyone, please give a warm virtual round of applause for Alish, who will be talking to us about Wayland for app developers.
Okay. Thanks everyone for the virtual round of applause. It was virtually great. All right. So for the talk today, I thought that instead of talking about things that are happening, which is what I generally talk about because I am a developer, I thought, well, what will developers care about when they start developing their applications? In general, we are talking about graphical applications, much like what Matthias was just talking to us about, like all of these fancy graphic effects and stuff. And I think that it's important to understand what is the process for our application to go into our user screens and displays and, well, wherever they use it, because this changes every day. So that's why I thought it could make sense to, well, talk a little bit about what Wayland is. I am also talking about Wayland specifically, not which is where they're going, at least for the community as a whole. Some of us are more advanced in adopting it than others, but in the end, it's not entirely the status quo yet. So it's still a technology that I am guessing that some of the developers need to embrace still. First of all, let me... Ooh, the penguins look weird. This used to be penguins emoji. I think that Big Blue Button doesn't like my emojis, but I mean, they were more cute as penguins, but sorry about that. Who am I? Well, my name is Aleix Paul. I am from Barcelona. I have been developing KDE software for the last 15 years, maybe more. I get old quickly. I am the KDB president as well right now, but well, I'm still a software engineer, and I work for Blue Systems doing, well, software development within KDE. I've been involved both on developing different applications within KDE Edu, for example, KDE Developer on our ID, but I've also been working as well as within Plasma, doing, well, our software center, and more recently working on Quinn, which is our, well, window manager back then and Wayland compositor nowadays, which is how I got to, well, thinking about this kind of topic. Now, a bit the history for those of you who haven't been around forever, and I'm not gonna even claim that I've been around forever, even if I've been around for 15 years, because in Unix time, forever takes much longer. X11, which is what, well, still a lot of people are using nowadays, was a system that was designed in the 80s in conjunction with Unix. I'm not gonna claim that I know what happened because I wasn't born even then, but I think that well, it shows two very things that are, I think, very important. One, that we've been working on technology that has been established over a very long time, and also that there was a need for a change because, well, the world has definitely changed since back then. Now, X11 and X3, which was the implementation that we, I guess, most of us started using when we got introduced in Linux, was developed for big mainframe computers. Ooh, sorry about that. Big mainframe computers, so that they could put it in a university, in a company, and everybody would, well, join and from their own dumb clients, and they would get, well, their own little windows and things, and get their job done in a big computer elsewhere, which is actually how we don't work nowadays. Now, we still do a lot of our work on the cloud, which we call it nowadays. Back then, it wasn't called the cloud. But, well, the graphical things, they always happen on our computers, be it, well, a desktop computer, but also a mobile phone. which is quite telling, right? Like back then, the graphics part was considered something hard to do, whereas nowadays it's the kind of thing that we relegate into every device because we're good enough at it. Anyway, moving into the future, which is actually when I started to be part of the community. There was this XGL project, which was all super fancy, which basically what it was doing was to include in the Linux desktop, the desktop, technologies that we had been getting familiarized with for example, games like OpenGL, so that our systems would be able to use the hardware acceleration that we had available, right? Something that I learned at university, and many of you will have as well, is that the universal way of making any program run faster is by making hardware ad hoc for solving that problem, right? And graphics was a problem back then, like I said from the beginning. And we got eventually hardware to do it that was, by 2006, it was already quite fancy. There were a lot of 3D based games already that people were running, even consoles and this kind of stuff. So it made a lot of sense to use it on our desktops. Now, this was something that was put on top of X11 because that's what all of our applications understood, and it was the only thing that we had that could talk to our graphics cards. And it kind of worked, and it had a very famous demo with a cube rotating between the different desktops, virtual desktops, which was fancy. And I mean, today it doesn't sound like that impressive, but back then it was like, look at what these crazy people are doing. And by the way, this didn't really happen in a bubble. This is around this time also Microsoft started doing that for Windows as well, and so did Apple for macOS. So this created this super complex kind of solution that was not really future-proof. So people started working into alternatives. X11 and Xorg already back then started to get adapted into these kind of premises, and so did so we started getting it. And if you today start using an X11 based Linux desktop, you will see a lot of these features already available. It's not like you need Wayland to do all of this stuff. But eventually, in 2013, according to Wikipedia, all of these dates are according to Wikipedia. I'm not a historian myself. Sorry about that. We started developing Wayland, which is what we are gonna cover during this talk today. Now, click. So why did we need other things? What do we, as application developers, now we need to think about two target platforms in practice rather than just the one, at least for a transitional time. Well, for starters, we want stability. The development of Xorg and compositors on top became like, it definitely works, and it worked for a good 30 years without, I would say without problems, but then it weren't my problem. So I know that a lot of people, sweated a lot during the process. And people eventually wanted to have this more simpler solution where from a compositor, you could decide how things work, how things communicate between one another. And the way you have as a maintainer to say, this is stable, this is something that I feel capable of delivering to my users, is by being able to somewhat control and be able to decide on what the stack is. This is something that we do get by Wayland through the newer design. We also are looking towards having performant graphics, right? So in the X11 model, we had the applications talking to the server, the applications talking to the desktop, well, the compositor, and there was a lot of moving pieces over there. What we have right now, though, with Wayland is a much simpler architecture where all of the applications or clients, like we generally call them in Wayland, talk to the compositor. The compositor is already doing graphics calls fairly low level or as low level as it wants to the graphics card, and the graphics card does its thing. Now, this means that there's a lot of the infrastructure that X11 was giving us for free that we have had to implement. But then this also means that if you right now tell the maintainer of your system, be it GNOME or Plasma or Sway or whichever, that something is not working as it should, they get to give you a proper answer rather than saying, oh yeah, this is a bug in X11, report it to them, problem done, which is something that sadly has happened, and it has put our position as a product in jeopardy at different points in history, right? This is not something that should happen. We should have the full ownership of what we deliver to be able to, well, solve all of the problems. And the other very important part is how the components communicate with each other. Like I said, on X11, I didn't say it. X11 was like a huge observer pattern where every client could see everything that was happening. There's something that has been tried to address in different ways, like for example from Flatpak. But in the end, you get all of the events that go into every client, and then you decide which ones you want because you know who you are yourself, right? But it's in the end possible on X11 as is to know what things people are typing on, well, text fields on another window, or to place ourselves wherever we want, and this kind of stuff. This is a problem. This is a security problem for starters because we don't want all of our applications to know about everything. We have not had a lot of problems about security on Linux, for example, or at least major ones that we know about, but it's only been because, well, people have been reasonably good at choosing where they get their applications from, but in the end, horrible things could have happened, and I'm pretty sure that horrible things have happened somewhere because this could just happen, right? Writing a keylogger for X11 as it is used nowadays still is trivial, and everybody can do it, well, sitting down in an afternoon, right? Whereas, but that's not ideal. What we do on Wayland instead is, since you only talk to the compositor will only be talking to you about the things that you're supposed to know about. This has another interesting ramification, which is the state machine that you end up getting is much simpler because every client is not depending on the states of all of the other clients, but instead that you just have the state of that is the conclusion of what the compositor has been telling you, but only the compositor and maybe the rest of the debug services that you talk to, and maybe hardware, but, well, not the state of every other client around you, which I think that is also part of why this is good news. So how does this work? I keep talking about the compositor and the clients. Well, let me show you this graph because graphs are always better at explaining things. Here it shows 3 applications. The applications have buffers. This is only depicting how it works for the rendering part, but I think that it's quite explanatory in itself. So every application, we have a set of buffers, which are, well, every frame that you want to that you want to render on the screen for your application. it will tell the compositor, I have a new one, or and you get to present it. Now the compositor will put it however they like. In Windows, it could be on any other way as well. It could be doing mosaics. It could be doing, like, we have different kinds of compositors as well, like Sway, for example, which is tiling. We have, well, the normal window like we do on Plasma, and they do in GNOME as well. Because in the end, it's part of a compositor's role to decide how these things should be working and how these things are working. This graph is a bit limited, though, because if applications could only send things, well, life would be very boring for everyone who wasn't a video player. The compositor is also connected to other hardware that we will be using for input. Think about touchpads, mice, keyboards, tablets, anything really. You can also think about virtual keyboard kind of use case. It's not hardware, but it's something that actually the compositor understands how it needs to be done. It will get the information and it will be sent to the application in the right way. And the compositor will be sending all of these applications to the applications, and the applications will be sending back new buffers with their updated information or whatever they need. Applications could also be talking about other stuff. It's not like applications can only talk about, tell about frames, but they can tell about anything. We will see a bit later how this all works. Next. Now, I would say that so far it's quite normal, and I would even say that's probably what you expect to hear. I am not sure. But what kind of implications does this have? Because in the end, what I think that we're all saying is that applications used to look a certain way on X11, and they actually end up looking exactly the same on Wayland. How's that possible? Why does this happen? And why does Wayland matter after all, right? But in the end, for application developers, this shouldn't change that much, because we're all relying, or most of us, we're relying on well, frameworks to do this kind of stuff. There is GDK, there is Qt, there's SDL, for example, which is used more for games. And these, they do support Wayland natively or through a backend. So it basically just works. And as an app developer, you can mostly assume that things work normally, with an asterisk that we will go through later. But you can focus on making your application great, and hope that the application will work on X11, it will work on Wayland, and possibly other platforms like Windows, Mac, Android that most of us support. They should work in general, right? Because in the end, painting into a rectangle is, well, as hard as it can be, right? That doesn't mean that all of them support them. For example, Electron and actually, well, Chromium and Firefox aren't all that ported yet. Firefox, you need to enable a thing. Chromium, I think that the next version is we'll start shipping it by default, with also an opt-in version setting. And Electron, being based on Chromium, is also lacking there, but hopefully soon it will start working. Actually, I think that the next Chromium 87, which happens in 2 or 3 days, not that much longer, they will have this option, and I'm quite excited about that. Also, something worth considering and keeping in mind is that while all of these support Wayland natively and properly, we also have a component called XWayland, which supports X11 applications. So if your application for any reason relies on something specific about X11, you can have your application go through XWayland. and this will make things work properly, as long, of course, as the compositor is doing things right. So today, for example, if you run an Electron application from, well, as they're meant to be used, you will have them running through XWayland, as well as the web browser, for example, also unless you don't set the environment variables. But it's slowly changing. And actually, more or less everything works as it should. And you should notice there's small details like, for example, scaling works a bit differently and applications look a bit blurrier if you have a scaling system. At least for us, I think that other compositors will have the same problem. Also, there are patches to solve that, so in the future it might not end up not being the case, but this is what you get today. But it's not a big problem. Like, many of us have been using Wayland only for the last few days, and we've all been able to do well, everything that we used to do on Linux without feeling sorrow. I've been talking a lot about this communication between the compositor and the client. What does it look like? And it happens through protocols now. Well, when your application starts, it will connect into a socket, and they will start communicating, much like, well, any communications happens through a socket, right? You write things, you get to write things, etc. This is not something that, even if you were toolkit developer, you would have to care about that much, because, well, on one hand there is libwayland and it's tooling that takes care of that. So, well, it's already somewhat abstracted so that you can comfortably have this kind of back and forth. As soon as you have to start looking into one of these protocols, you will start seeing this XML file. So I figured it would be useful to show a little bit about what it looks like. So I created the most innovative protocol called the protocol potato, which does nothing, and it's not supposed to work or anything. It just meant for you to see what kind of things it does. So, I mean, this is a perfectly valid XML file, and if you pass it to well, Wayland tooling, it won't give you an error. It just will be useless. But what you can see is that you have a protocol. Each protocol will have different interfaces that you could see them like as objects, if you want, I guess. Different interfaces will have different kind of items, mostly requests and events. And you should read these protocols as if you were a client. So in this case, a client can request to get a potato and will eventually be notified about the cooked event, right? So when you're a client that implements this, you will have this kind of semantics allowed. You can see also the request can have arguments. So you can say get the potato for this surface. No, sorry, here it's getting a potato and it's the surface that is returned. But you could pass things like give me the potato number 3 or give me the potato called banana, whatever. And eventually it will be getting a callback that is usually like a function pointer or a virtual function if you use object-oriented programming that about the cooked signal whenever it's emitted. If you're a compositor, though, which none of you are, because here we are app developers right now in the context of this talk, what you do, though, is the get potato is something that you never call, that you're called to offer potato, and the event is something that you do send, right? So eventually, when the event happens, you get to emit it for your clients to know. And something that I think it's useful to understand is that when you do send these things from the compositor, you say to which client do you want to send it. I mean, it can be to all of them, but not necessarily, and actually usually not all of them, but whoever you're replying to or anything in this regard. Now, this all sounds very abstract. How do we turn that into something that looks more or less practical? Well, we're going to get to that later. You can see the protocols available officially in the repository that I pasted on this. That you can see over here. Maybe somebody can put it on the chat or something. But essentially, you will see a bunch of them. They are split into two big categories: stable and unstable. Stable, what they mean is that they are not meant to change in the foreseeable future. Unstable is that they might still be developed. All of them, they are agreed upon by different actors in the community, being the different compositors. They don't all need to agree that they are all useful and to implement them, but at least there needs to be a critical mass that is using them and implementing them. Otherwise, well, it would be quite frustrating to find something over there and say I'm gonna use this protocol because it's exactly what I think, what I need as an application developer, but then not find any compositors that do it. Most of the things you will find over there should be supported. I think I mentioned there's the stable ones and there's the unstable ones. The unstable ones, they could change over time. And kind of the idea is to polish the unstable ones so that they can become stable over time and, well, enjoy life. Now, these are the ones that you should care the most about as an application developer, because they are the ones that will more or less be implemented by all compositors. But then, since, well, creating a desktop environment is not always the simplest of tasks, we've collectively created a myriad of different protocols that are used. For example, in Plasma, we have several ones for communicating with Shell, which is definitely a specific kind of client that needs to do and to know about things that other clients shouldn't know about or will not need it anyway. Things like listing windows, this kind of stuff. You don't want, or you don't need every application to know about this kind of stuff. So we only send that to the privileged kind of clients. Others also have similar things. Some of them, for example, also extend what the standard ones do. But in general, these are some that you shouldn't need. I did place them here, though, because they might be useful for you. And as an application developer, if you see that something is super important for you, you can always say, how about we standardize this one because I want to base my application on this concept. And otherwise, I cannot have my application do its own thing. And this is something that could definitely happen. Some that we've created in the past has been shared between different projects, and I could see them moving into more stable spaces eventually over time. Now, there was the XML file, and there was the libwaylen thing I told you about. So how do we mix them in a way so that you don't have to become a weird protocol ninja, so that and that everything reasonably works? Well, there's these tools that you can use to generate code from an XML file that will work for your application. So basically, what you do as an application when you want to interact directly with a protocol is that you will create a registry. The registry will announce to you all of the different interfaces protocols that are available, and then you get to say, all right, I am interested on this one, give me this one, and I will work with it. And what you will do is that, or you will get an instance of a weird object that you will get to pass into one of the classes generated by these scanner files, classes or objects, depending on the kind of of language that you use. There's a Wayland scanner that will generate C .c file and a .h file. The Qt Wayland scanner, same-ish, but with C++ things. There's the PyWayland scanner, which I have never used, but it generates Python code, I guess. I saw that there were others, like for Rust and this kind of stuff. But in general, the idea is that since it's not tied to any language or any technology, but you definitely want to communicate easily with the protocol, and you should be able to do so with the semantics that are provided from the XML file, which is, well, what you care about at that point. Of course, if you ever decide to come up with a protocol, you will have to implement it for your client and then for all of the compositors. So beware with doing that, and well, don't try to consider this a solution for everything. There's also the discussion about when you should be using Wayland protocols and when you should be using dbus, for example. There are things that have been using dbus that actually theoretically and technically could be ported into Wayland protocols, but there's no good reason to do that, and we will never probably do it. Like, I don't know, I'm thinking power management, right? You have a dbus service that is already doing its thing, and well, it doesn't have a big problem with that. So it could make sense to have applications not be exposed to those, but in general, as soon as they see them, they should be able to continue working with these dbus interfaces, and that will continue being the case, right? So as compositors, we have several of them already implemented. There's Weston, which is kind of the reference implementation, and it lives together in FreeDesktop with Wayland itself. There's Queen, which is the one we've been doing for Plasma. There is Matter for GNOME. There's WR Roots and Sway. WR Roots, as far as I understood, is a framework to create compositors, and actually there's several of them already based on it. And then there's Sway, which is the one that was created by the people who created the WR Roots, which is a funny-looking one. And then there's the Qt Wayland compositor, which is well done by Qt for doing more embedded kind of things. Although some people are creating proper desktop environments around it, so that's kind of interesting. Things to keep in mind as an application developer. Well, I think that something that has been a bit of a problem since the beginning for certain applications has been the positioning. If your application is weird in that it needs to be placed in a specific region of the window, you might have problems doing that. On X11, you could say, tell me where I am, and it would tell you the X and Y of the position of your application, but it would give you like all of the dimensions of your windows, which you still need to know because you need to know how much pixels you need to render at any moment. But what we don't know is about the positioning. And from that, we can derive, it's not just about the positioning itself, it's about how the compositor now is the one with authority about where things are placed. Something that also something that we used to do on X11 was the braces window, and a window decided to move on front, and well, because it thought that it was very special and important. It is something that it cannot be done right now. We're working on it, but well, it's the kind of things that needs to be thought properly. Another thing that happened is that there were a lot of processes that their function was to well, see what others were doing or making things happen on other clients. For example, think of a virtual keyboard, and X11 you could implement a virtual keyboard by saying, and now the X is pressed and now the Y is pressed. But this is kind of weird, right? You don't want a random application to be sending keys to another random application. You can implement virtual keyboards on Wayland right now, and it works fine, but it needs to be done properly. And by properly, I mean using a specific protocol that is about that rather than just saying this is what people definitely need. They need this event as if it was coming from the keyboard, which is kind of a weird premise. If you want to learn further, there's the official documentation, which is fine. It's quite extensive. There's also the Wayland book, which was created by one of the Sway or the lead Sway developer, I think. It's pretty good. I ended up reading things over there when I was starting, and I needed to understand why things were like they are. So I recommend you to take a look and see what's what over there. Other than that, well, I mean, there's definitely tons of other documentation all over the internet. If there's something specific you need, I'm sure that I or maybe other people will be able to help you with that. But yeah, if anyone has any questions right now would be the right moment to talk about them.
So it looks like we have one question in the shared notes. It says, what do you think about the KWinFT fork?
Well, the QueenFT fork, it's something that you can ask the main developer. He used to work with Plasma on it. He decided that he wanted to work alone, and he's now working alone. Or I don't know if he's working with other people, but I don't really have. I don't know why it matters.
Okay, next question is, what is the status of Wayland for? I'm going to butcher this.
Xphase and Mate or Mate.
There we go.
Yeah. Well, I wouldn't know. You would have to ask their developers, which is kind of the thing that you have less of a shared infrastructure over there. As far as I know, which is not that much, is that they were using GNOME infrastructure for this kind of thing. So I would expect them to be able to use Matter. But I am sure that somebody on the chat here will be able to give you a better answer than I have right now.
It looks like that's all the questions we have. Thank you, Alesh. As always, a wonderful presentation. And we will see you around, I suppose.
You'll see me around. Thank you very much, everyone, for listening.
Okay, everyone, we will be back in just under 10 minutes for our next talk.
And the next talk is being held by Elizabeth about Linux applications on mainframes. Can your Linux application run on a mainframe?
All right. Hello, everybody. So thank you for coming. This is my first time at the Linux Application Summit, but my background, I've done a lot of work in Linux application space. I spent a lot of my career working on Ubuntu as a developer and a community outreach person, and that was all volunteer work. And then I moved into other areas of open source. So what brings me here today is to talk to you about what I do for my day job these days. So I work over at IBM, and I was looking for sort of a change in my career. I was really interested in Linux desktop, and then I was working as a Linux sysadmin for about 15 years. And I'd gotten into the cloud world and had been working on OpenStack and containers and all kinds of things that we think of when we think of the modern like DevOps movement, SRE. But when about a couple of years ago, I thought, you know, everyone else is going over to Kubernetes and working on that cool new infrastructure thing, but I was wondering what else was out there. So I was approached by IBM. They said, "Do you want to work on mainframes?" And I was like, no. But they convinced me. I was able to talk to a bunch of their technical staff. I was able to dive into some of the open source work that's being done on the mainframe, which I'll talk about in this talk, and the state of Linux on the mainframe, which it turns out has been around for 20 years. Linux has been running on this hardware over 20 years, actually. So that is what I'm here to talk to you about, and how you can get your application to run on it. There's a bunch of free resources out there that allow you to develop an application on this platform. All right. So the first question I want to answer is what exactly a mainframe is, because when I started talking to IBM, I wasn't sure what they were. I knew they were big computers. I know they've been around longer than I have. But most of what I knew about mainframes was kind of like they were this vague, big computer that I've never seen and probably would never work on because they're really complicated. And they, you know, I didn't think that they ran the software that I was interested in. I didn't think they did anything that I would have ever crossed paths with. I also didn't realize how pervasive they still are in the industry. This mainframe business is a multi-billion-dollar industry. Every time you swipe a credit card, there is a very, very, very high chance that it is going through a mainframe somewhere in the world. Whether it's, and so it's huge in finance, it's huge in health tech, it's huge in the insurance agency. Most of the airlines still run on mainframes. So that's the first thing. And this picture here is a photograph of a mainframe in a data center. So these days, they don't take up a whole room. They each like section of the rack, there's 4 of them in this picture that have the blue on it. Each section of the rack is 19 inches wide, so they fit into a standard 19-inch rack spot. You no longer have to have a special place in your data center for this mainframe. When you open it up, this is what it looks like inside. It's a little hard to see because this is so small. But the main things that I wanted to point out was that there is no storage inside of a mainframe. All the storage is going to be external. So you attach a storage device. There's a bunch of companies that make them. And then inside, it's pretty much all processing power. So you've got your CPUs, your memory, your PCIe cards. And so like the 5 red boxes in the middle are your CPUs, which I'll talk about in a moment. And then most of the rest of this is all of your like IO cards, your cryptographic cards, all of the specialized cards that make a mainframe really special and very good at processing data. In the model that was released last year, you have a water-cooled option, which is pretty much the standard for these systems, but they also have an air-cooled version. And you can get this in either 1 frame, 2, 3, or 4 frames. So if you get the 4-frame one, like pictured here, that's like the totally maxed out system that you can get. And you can cluster mainframes, so you can have multiple. And so you can scale horizontally that way. Yeah, so this one actually is the water-cooled system here. And those CPUs. So the really key thing for this entire talk is that they are not x86. Depending on who you talk to, you'll see people refer to it as IBM Z, which is probably how I'll refer to it in the rest of this talk. And S390X is how you might see it if you are in the open source world or in the Linux world and are looking for the binaries for this architecture. If you come from sort of the mainframe background, you might refer to it as Z architecture. The CPUs themselves, if you have a maxed out system, there are 190 of these processors inside that 4-frame machine. Each processor has 12 cores, and each processor also has really big caches. And that's one of the defining characteristics of this architecture, is that these systems were built for processing data. So if you think back to the 1960s when the first ones were released, the only companies that needed computers were ones that were doing processing, ones that were doing a lot of work with data. So they were either processing data or storing data. So as we think back to the industries I mentioned in the beginning, we're thinking about banks, we're thinking about airlines, and ones who need to have data, because there was no Facebook back then. Like, you didn't need to store random data about people. It was really industries that were data focused back in the day. And the systems are still geared towards data. In a fully decked out system, you get 40 terabytes of RAM. I mentioned all those PCIe cards, so there's 12 drawers of those. And there are also these processors called SAPs, which are dedicated purely to I/O. So when you're doing I/O, you don't have to take away from the general processing power. There are specific processors in there that just handle I/O. And again, this is because of the data focus of the systems. So there's an interesting question or comment in the chat, and someone mentioned that she had seen S390X while doing some work on SUSE, and they didn't know what it was for months. Yeah, so that is a great segue into this slide. So I wanted to stop for a moment and just talk about other architectures in general. So the Kubernetes project is just one that I like to bring up as an example, as an infrastructure person myself. They release binaries for their servers and their clients in multiple architectures. So if you want to go through the list of what they release their Kubernetes server as, one of them is AMD 64, which you're probably familiar with. That's your standard 64-bit x86 machine. That's going to be in your standard laptop, and not much longer for Apple, but the desktop and server. It's pretty much what you're going to get if you load up any random system. And so that is. Oh, and if you're interested in like architecture history, finding out how x86 became the dominant architecture in the industry is a fascinating story, and it has very little to do with technology. There's a lot of politics involved in like back in the 86 days, but that's way off topic. Another one you might see around is ARM. Of course, ARM is and ARM HF. Those are what are in the older cell phones, and also the Raspberry Pi 1 and 2. So that's a 32-bit ARM. ARM 64 is the more modern version of ARM, again 64-bit. That's ARM, so that's in all the modern cell phones, both Android and the iPhones, and that's also what's in the Raspberry Pi 3 and 4. So if you've ever played around with the Raspberry Pi, you have gotten your first taste of different architectures. Some of the stuff won't run because you have to compile it for that architecture. The PPC 64, so that is PowerPC 64-bit. You'll find those in IBM's Power series of servers, so that's the Power 9 and the Power 10 systems. The 64-bit PowerPC was also used in the Wii U system and the PS3 and the Xbox 360. So that like era of game consoles. I guess Wii U was a little after the other two, but there was a lot of PowerPC in gaming consoles for a while there. The LE, that's in parentheses, which is what Kubernetes releases as their binaries, that stands for Little Endian. And that means PowerPC is typically big endian, which has to do with how memory is handled in the system. But the version that is becoming increasingly popular is the Little Endian version, because every other processor I've described on this list is a Little Endian processor. And that matters when you're porting software. So PowerPC has both versions. And then coming again to the S390X, which I'm talking about here, that is big endian. So on this list, PowerPC has both, S390X is big endian, the rest are little. So that is your very quick tour of hardware architectures. And I had to try really hard not to dive too deep into this because you can get, there's like many, many talks about this topic. So mainframes, IBM Z, where did these things come from anyway? So one of the things that really pulled me in when I was learning about this architecture and these systems was that they have a really strong open source legacy, it turns out. Like I was thinking, IBM controls everything and they have this proprietary ecosystem and this whole thing. But when I was reading about it, it turns out that there's this organization called Share. It was founded in 1955. And so it is the longest continuously running open computer user group in the world. So that's pretty cool. They just celebrated an anniversary this year, and they had to have a virtual event, which was sad. But next year we'll all get back together. And one of the key resources back in the 1950s was the Share library, and that's a library of software that the developers of these first computers, the first commercial computers, were sharing freely among each other. It wasn't really open source in the way we think of it now, because there wasn't, licensing and legal stuff getting away. It was just, source code was the only way people could share code. In 1959, the organization came together and released the first operating system that really ever existed that had like certain components that you would generally call an operating system. So it was called SOS. And if you go to Wikipedia and read about SOS, they say it's one of the first instances of commons-based peer production, now widely used in development of free and open source software such as Linux and the GNU project. So it's funny to me because when I look back at histories of open source and histories of things like Linux, Unix plays a very, very like a starring role in all of these stories. But Unix only dates back to the 1970s. Here we're looking back all the way into the 50s of people sharing software. So Share is super cool. There's lots of great people who are part of this organization. And it's all focused on mainframe. I mentioned at the beginning that Linux runs on the mainframe, and it has for over 20 years. Again, like with this open source legacy, like this all started out as a community project as well. If anyone was around in the late 90s playing around with Linux, this was the era of like putting Linux on a dead badger. That was a series of essays about, about like funny essays about Linux and then where it was in the late 90s. So people were just putting Linux on everything because you could. It was open source. It was really lean at the time, and people were trying to experiment and geek out about it. If you do go into the history of Linux, it's on IBM Z. It's really fun because if you're a Linux nerd at all, you'll totally see yourself in their reasons for porting it. They ported it because it was there, like it existed. It seemed fun. They ported it because it was an interesting challenge. And then if you go down their list, they're like, oh yeah, the IO is really fast and it does all this great stuff, so it'd be cool to run Linux on it. But at the heart, I know it's those first few reasons. And so there was a community effort working on this, getting it running. And then it turns out IBM was simultaneously working on a Linux version as well. And so they released their first series of kernel patches. I think it was a 2.2 kernel in December of 1999. These were pretty much just like blobs, like here, this is how to get it to run. In October 2000, SUSE Enterprise Server became the first still in production enterprise Linux to run on S390X architecture. There's an interesting story here. So I know that it's really just a marketing thing, right? Like when SUSE rebranded to call itself Enterprise Linux Server and all this stuff. But the first SUSE Enterprise Server was called Enterprise Server because it ran on S390X. It was Enterprise because it ran on enterprise hardware. The x86 version of SUSE Enterprise Server actually came a few months after the mainframe version, which is funny to me because then I get to tell people that the SUSE Enterprise, the x86 version is the port. The mainframe version is the original. I know it's not true, but it's funny anyway. So SUSE was the first. Red Hat, like just a couple months later, they followed. They were the second one that's like still an enterprise Linux that runs on the mainframe. And then long, several years afterwards, late into 2016, Ubuntu came to support the platform with their 1604 release. So when we talk about Linux on the mainframe, it's not some special IBM thing. It's not some special proprietary thing. It really is like these Linuxes that we know and love already. I also have a slide coming up with other distributions, the community supported ones that are all on there. So at the beginning of this deck, this presentation, I showed you some mainframes with a blue cover on them. The ones with the orange cover are called Linux 1, and those only run Linux. So there's a bunch of traditional mainframe operating systems, proprietary ones that IBM sells that exist out there, but the Linux 1, it only runs Linux. The first one from IBM was released in 2015, and we called them the Emperor and the Rockhopper, named after penguins. In 2017, just 2 years later, the Emperor 2 and the Rockhopper 2 came out. And then just last year, the Linux 1.3 came out, and they dropped the penguin names. I don't know why. I guess the whimsy had run out of IBM. But we don't use penguins in the marketing anymore, which is sad. But here we are. So the point here is, like, I'm not here to sell you one because that's not my job, and I don't know how. I don't even know how much they cost. But the interesting thing here is, like, not only has IBM created a Linux-only mainframe, they keep creating it. Every 2 years, we've been coming out with a new one. Like, there's clearly an audience here and people who are using this and a real community around this, which is one of the things that's been most exciting for me to learn about in this role, working at IBM on open source things. So this is what we're here to actually talk about, running your application on a mainframe. So we just had that Wayland talk, and I know a lot of the talks are very geared towards graphical applications, and that is where I'm going to disappoint you. Because if you have a graphical application, it's probably not going to run on the mainframe. I don't know if Xserver has actually been ported, but I don't know why anyone would bother. Your interaction with the mainframe is really text-based. So you're either using something like Unix system services, or you're using Linux, or directly. The way you interact with the systems running on it is through something called ZVM, which is a virtualization technology, or you're running it on something like KVM, which runs a super slim Linux, like on bare metal in the mainframe, and then you run KVM on top of that. So the way you interact with it is very not graphical. So this is the first thing. There's not really graphical apps on the mainframe. If you are running something like a web app, if you're using Node.js, if you're using Python frameworks, this is perfectly fine. Node and Python interpreters have been ported to IBM Z. They've been around for years now. And so typically if you're running Node or Python or something, like it can just run, it's fine. If you're focused on server-side apps, again, like this is what these machines were made to do. If your app is data-driven, I've talked about this already. Like seriously, that is literally what mainframes were built to do. They were built to deal with data. And all the engineers, thousands of engineers who are still working on the new processors and the new hardware, like their focus is all about data. Which is why we like one of the big pushes for IBM is like the hybrid cloud story, because the cloud is like a great technology for people to be using for their infrastructure. But if you're really focused on data transfers are really expensive. Data storage in the cloud is really expensive, and x86 was not developed for data processing like the mainframes were. So if you do have a data-driven app, I highly recommend checking it out. Also, if your application is somehow dependent on encryption, oops, I wrote encryption and encryption. I meant encryption and decryption. Like the cryptographic hardware in these things is one of the most exciting things for me when I started learning about this, because there are crypto coprocessors inside of every CPU, and so you don't necessarily have to take away from general computing power to do crypto, which means you can encrypt like all of your data. You can use IPsec to encrypt it in flight. You can use dmcrypt on the kernel level to encrypt it on the disk, and you don't pull away from general processing power. I have a couple of servers behind me in here, little x86 ones, and it just doing encryption on these machines takes like a ton of my CPU. So I'm not super thrilled about that. I should have gotten more powerful CPUs in these things, but encryption really does chew up your CPU. And one of the things that we've been sort of telling people about is that blockchain runs really well on a mainframe. If you were to like purpose build a machine for blockchain, it would probably look a lot like a mainframe. Between the data processing and the encryption stuff, like that is what they're built to do. So now getting to the question, like, is this some strange like side thing? A couple of people mentioned in the chat that Firefox is built for S390X. So hey, there's a graphical app that's built for it. I'm gonna have to play around with some graphical apps after this, because I don't. Yeah, if Firefox is built for it, then like there's definitely some stuff going on there with X. So yeah, there's lots of other projects out there. This one is kind of like our like vanity slide. There is not a comprehensive list really. I'll talk about it later, but we do have a software search tool that searches the three distributions that I mentioned for packages. But this is kind of like when people want to see like real projects are being ported to this architecture, like yes, they totally are. You'll see also there's community versions of Linux, so Debian, OpenSUSE, Fedora. ClefOS is a version of CentOS that's maintained. It's an S390 export. And Alpine, the one that's commonly used with containers, that one's been ported. That was done by, I think a mentee at the Open Mainframe project ported Alpine. And then like all these other ones. There's a link here that I also link to like in the slides. This is just an image. And these ones are like the list that like IBM maintains concurrency on by working with the open source community. But a bunch of open source communities, like people just do it on their own. Like they maintain some of the ports. And I think we have some of the people in the audience who've worked on this stuff. If you're into containers, Docker Hub has a way to search by architecture. And so there's a bunch of official images out there for S390X as well. So you don't have to focus just on one side. You can look into the container world too. There's a bunch of stuff you can grab. So the first thing I wanted to talk about is with regard to like specifically dealing with open source. The first thing is like, how do you find other software projects that are already running on S390X? So my first recommendation would be, actually, which I didn't list here, was search in your own distribution. So if you've got a VM, which I can tell you how to get, running on Red Hat, you just do a yum search and see if it's already there. The first thing I did when I got my first VM on S390X was I installed IRC, the IRC chat client, and Screen. And I hopped on IRC and I like piped a bunch of output to my friends. And I'm like, look, I've got a VM on a mainframe. How cool is that? I mean, it was cool for me. My friends seem to appreciate it. But I can't imagine that like a text-based IRC client was something that someone like a customer requested or someone went out of their way to create. I think it was actually just something that Red Hat was like, let's just build everything we can, and it passed the tests and it worked, and so they shipped it. So cool. Like a lot of the software really just builds and works fine. If it's not part of your distribution, you can go direct to the project. As you saw the Kubernetes download page, you saw there were S390X binaries. You can ask, like, if you're a mainframe customer, you typically have a vendor who's providing you software as well. So you can talk to the vendor. There's this really cool website that the Open Mainframe Project, which is part of the Linux Foundation, has put together. So it's called landscape.openmainframeproject.org, and it allows you to scroll through a bunch of projects, kind of like the slide I showed you. And it's actually an evolution of that site. So we created the slide, and the guys at the Open Mainframe Project were like, hey, that's really cool. We did that. And interactive version. You can click through and see what the projects are about and the status of the S394 stuff. IBM has a list of verified software, like not necessarily that IBM supports, but we keep an eye on the ports and make sure that they're being updated by releases, and that there's a specific interest in. I mentioned there's an IBM Z search on Docker Hub, and then a project that I'm working on right now is the Open Mainframe Project software discovery tool. And that one allows you to search Red Hat Enterprise Linux, SUSE, and Ubuntu for binaries. So if you search for whatever software you're looking for, you can find it in that tool. It's very early days. We're going to add a bunch of other stuff to it too. So we don't want to just search Linux distributions. We also want to search for ZOS for traditional mainframe operating system stuff that's open source, and also search pretty much everything we can get our hands on to make sure it's like a comprehensive search tool. So that's finding open source software. The next step is, if you have open source software, if you're developing open source software, what can you do to actually port your application? So again, Open Mainframe Project, like this is probably the reason I took the job with IBM Z. Being able to see a Linux Foundation sponsored project that was not controlled by IBM, that had a bunch of stakeholders, like their board and their technical board. They're not even dominated by IBM. IBM, I think, has like one seat on these boards, but they're a bunch of companies that got together and decided that they want to do, like, have a place where they can do all their project hosting for like projects that they're developing collaboratively. So the Open Mainframe Project, if you have a mainframe specific application, they'll do like your full project hosting. So that like they'll put it in their GitHub org. They'll give you a mailing list at list.openmainframeproject.org. You'll get a Slack channel. You can be interviewed on their podcasts and post on their blog. They have forums. So like all the resources that you'd expect. A CI/CD system. For the software discovery tool, they're going to offer us web hosting space so we can actually host the tool somewhere once it's in that state. But if you have an application that's not specific to the mainframe, they also provide resources for third-party open source software projects. So just off the top of my head, I think Debian is one of the ones in this that gets support from the Open Mainframe project, and there's a bunch of other ones out there on their website that get VMs that are like given to them through the Open Mainframe project. They also have an annual conference. It was supposed to be in person this year for the first time, but alas, nothing is in person. So their first conference was in September, and it was really cool because it's just the ecosystem around mainframe development and open source is huge, and it was really impressive to me to see everyone speaking there. So the next one I want to talk about is the Linux One Community Cloud. So this is the one that I do most of my work on. If you go to developer.ibm.com/Linux1, it will give you a form to fill out in order to get access to a Linux VM. That is a VM that's good for 120 days. It's actually a really nice VM for a free thing that we're giving away to people. It's got a really big chunk of RAM. The CPU is really great. It's a really nice machine for nothing. So this gives you 120 days of access. And the secret here is if it expires, you can sign up again. You have to get a new VM, but you can sign up multiple times. So that's really cool. And so one of the things that we do is we encourage open source projects, if they're interested in doing this porting work, is to hop on the Linux One Community Cloud first, see if their application builds, and play around with it a bit. And then if they're interested, they should reach out more formally to either the Open Mainframe project or IBM. I'm usually the contact person for this, but I'm actually about to go on maternity leave, so I'll be gone for a few months. But there's other folks on my team who you will be directed to actually talk with IBM and get a longer-lived virtual machine. So we support, I think, probably about 30 projects formally in our open source sphere, and then IBM has business relationships with a bunch of other projects. So if you're a project with Red Hat or Microsoft, there's probably some sort of like official arrangement there. But if you're just like a normal grassroots, like old school kind of open source project, you'll be working with me because those are the ones that I'm supporting, because I'm like, part of my job is outreach to the less corporate backed open source projects. And then here's a link here for the Linux One Community Cloud community, and that's a forum and a blog and like just ways that people are collaborating and sharing things on the Linux One Community Cloud. And we just launched that, so there aren't very many people there. Most of the blog posts are from me, but it's one that we're growing because we want people to be able to share their experience. Another way, so my suggestion is to start off on something like either the Open Mainframe project offerings or the Linux One Community Cloud. And then once you know that your software builds, you can use something like the Ubuntu Personal Package Archive. And that's on Launchpad. So if you're building Debian Ubuntu packages, this is really where you want to go. So the Personal Package Archives allows you to create a deb, so you do have to know how to create a deb package. You upload the source files for your deb package, and then you can build your package, and then you get like a URL where people can put it in their sources.list, and then you have a way to deliver your software as well. So by default, it builds for AMD 64. There's a little checkbox that you can build for Z Server, S390X. I think they call it IBM Z Server, but anyway, there's a little checkbox. So this is just like a simple app that I wrote in Golang, like a hello world, and I packaged it for Debian or Ubuntu, and then I uploaded the source and it built it for me on Canonical's mainframe. It's like, cool. So that's on the Ubuntu side. If you're using, so you can also use the OpenSUSE build system or build service that SUSE hosts. That will also build your package for S390X. I don't remember if you have to actually click it or if it'll automatically build it for you. I think it'll automatically build it for you. And if it builds, awesome, like you're on your way. So OpenSUSE build service, build.opensuse.org. And that again runs on one of the mainframes that the SUSE company has. In this case, you do have to have, just like with the Ubuntu PPAs, you have to know about deb packages. With the OpenSUSE build service, you do have to know a bit about RPM packaging. But I mean, I wouldn't say it's easy, either one. They're not easy, but they are very well documented, so it's something you can learn. Another way that we have for testing and keeping up your system is we partnered with the Oregon State Open Source Lab, the OSU OSL. I love these folks. They do so much great work for the open source community in a very independent way. But they have a Jenkins service that they run that just has S390X builders. And so you can, if you're already using Jenkins, you can add the builders that you get from the OSU OSL to your Jenkins, and then you can build it into your CI/CD pipeline. And this one's great because it's open source and it's run by some really great people. Sort of sticking with the CI/CD train here, Travis, which is proprietary, but they have a beta trial right now for open source projects. And so you can build for multiple architectures. I just put the docs link here for multi-CPU architectures because they now support ARM, S390X, and PowerPC. So they have builders for all three of them. And if you're already using Travis, it's really just a simple edit in your Travis config to support other architectures. So again, probably make sure your software runs first, and then dump it in your Travis config, and now you have builders. I think you also have to have your project on GitHub in order to use this, but you can see in the documentation what requirements are there. And that is where I'm winding down. So those are the free resources available and how you might go about it. And I wanted to sort of close out by talking a little bit about programming languages here. As I mentioned, in order to run your code on an architecture that is not what you wrote it for, the compiler or interpreter has to run on the architecture. So if your code is compiled, something like C or C++, then the compiler needs to be ported. If it's interpreted like Python or Node, those interpreters have to be written for the architecture. In the case of Z, like that's really straightforward. Most programming languages you're going to encounter have already been ported, so that's great. But you do need the compiler or interpreter there in order for it to run. I also mentioned that it's big endian, and that gets you when you start doing memory-specific operations inside of your code. So you may start running into endian errors, which is going to be very new for a lot of you. But I don't see it super often, honestly, unless you're doing really complicated data stuff. But what I will say is that your code will probably run. Like, give it a try, build it, and see if it works. If not, one of the things that we found, because it makes sense, is that like a higher level language, something like Node or Python, like those tend to run really well because they don't have as much hardware interaction. Like a lot of that is abstracted away, and that's what it means to be higher level. But lower level languages, they do more hardware specific operations. So you may run into some things there with things like the when you're working with C code. So it's more likely you'll run into endian errors when you're running C. It's almost unheard of if you're running like Node, unless the Node app somehow interacts with hardware, but that's incredibly uncommon and would be a very specific use case. And I like to tell people, like, when they start porting their applications, or when they start moving their like Node applications over, they're like, oh, it's going to work, it's going to be perfect. Especially people on my team who like are totally into this. And I'm like, okay, in a perfect world, absolutely yes, all these high level language will work flawlessly. But I will tell you right now that like part of like a big chunk of my job when I'm working on porting stuff is dependencies. And what happens here is sometimes there are dependencies that are outside of your control, or you do have to start building some things that haven't been ported yet. And it's a very good thing I take very good notes, because I could end up like really deep down the rabbit hole, like why am I building this one thing again? Oh, because I need it for this other thing. So that can happen, but I said don't let that scare you off. That's actually kind of fun. And that is where I wanted to conclude. So I think we have a couple minutes for questions if we have any. But thank you so much for coming.
Thanks for it all. We have some time for a couple of questions. The first question goes like this. At the OpenSUSE plus LibreOffice conference, there was a talk about emulations, containers, etc. YouTube link. One of the points brought up was about having smaller hardware of S390. Is there any consideration from IBM on lowering the barrier to entry and alternative to the Open Mainframe project?
That is a great question, and I don't know. I mean, I really wish there was, because we've been talking, we talk about it, like even internally, like we want a baby mainframe. We want just like a little tiny development box that we can just play around with, and it comes up in the community often too. But unfortunately, that's not. I don't have insight into any of that. I don't know. But yeah, I really wish we could just get a baby mainframe.
And the next question is, what kinds of applications are mainframes bad for?
So I mentioned like what they're good for is a lot of data-driven stuff. If your app, like if your world is just like hosting a web front end and you're not dealing with a lot of data stuff, like if you're really just pulling from different backends that have nothing to do with data, if you're showing a lot of things, like I wouldn't recommend it to your standard just like app-based startup. Like mainframe is not really appropriate for everyone. Like if you really are doing data and you need it to be reliable, like I think of social media, or like YouTube went down the other day. Like the world is not going to grind to a halt. And they're not really doing, they're doing big files, but not like, I mean, just because of the amount of stuff they're doing, it is actually really like a lot of data, but that's sort of an artifact of what they're doing rather than the intent. But yeah, like if you're just running a web app or if you're running an app on the phone, like for the most part, those are not going to be great for the platform. It's going to be a waste. But if you are doing a lot of data or data crunching.
And that was all the questions we have time for. You still have 2 questions left in the shared notes you can answer.
Yeah, I'll have a look. All right, thank you.
Thank you so very much, Elizabeth. I hope everyone enjoyed your presentation as much as I have. As Luna had mentioned, there are still some questions in the shared notes, and if you'd like to type in some responses, please do so. In the meantime, we are taking a brief recess and we'll return 5 minutes after the hour with app image packaging using App Image Builder. Hello, everyone, and welcome back. Our next talk will be about app image, and I'm pleased to welcome, sorry if I say your name incorrectly, Alexis to the stage.
Hello, Alison. Thank you. Yes, it was correctly. Let me share my webcam. Can you hear me properly?
Yes. We can hear you just fine.
Okay. Hello, everyone. Okay, let's start. Hello, everyone. My name is Alexis Lopez-Zubieta. I work as developer of the App Image project. I've been a contributor for about 3 years now, and I will be talking about app images in general and how to make them using App Image Builder. Let's proceed. App Image has two main design premises. From the user point of view, they have to be easy to acquire and to run, just like we do with Windows or a Mac application. And from the developer point of view, the application should be able to run in almost every GNOME Linux distribution, not having to make a package for every single Linux distribution. Now, an app image has this structure. It's a main executable and a compressed directory. This executable will mount the directory, is infused, and will run the app inside. The payload, as we call it, is a read-only image containing the app binaries that are and all the other resources that it might require to run. An app image, it's all batteries, includes all the batteries and all the stuff that an application might require to run. It has very few external dependencies, only a few graphical libraries, SSL, and other libraries that might come in almost every Linux distribution. Some kind of app images includes more dependencies than others. App Image Builder is one of the tools that include most things. Why? Because we are looking for a maximum portability, and of course, no installation will be required. Okay, next slide. Okay, App Image Builder. App Image Builder is a new tool for creating app images. It is recipe-based and has assisted recipe generation. The resulting app images will be backward and forward compatible and also can be created in modern systems, unlike other existing tools for creating app images. Also, it has the ability of patching fixed path at runtime, which means as a developer, you have control over your application, but you don't have control over your application dependencies. If a dependency has a fixed path that cannot be changed at runtime, you will have a hard time creating an app image of it. Now with App Image Builder, this is solved. Okay. Next slide. Okay, the App Image Builder has a new payload structure. It provides a custom entry point named AppRun. It embeds libc, glibc, LD Linux, and also at runtime, it compares the version of the glibc embed in your app image and the one running in your system, and picks the newer one to run the whole application. Also, it has runtime hooks. These hooks provides the path intersection ability and also allows to keep the runtime environment of your bundle confined. This is not sandboxing, this is just for avoiding that the runtime of your bundles get mixed with your system or and other application runtimes and libraries. Okay. Now I would like to show you more how to do it with a functional example. In this case, I'm going to be packaging GNOME calculator. I'll share my screen right now. Okay. Can you see it? Okay, the first thing is to, of course, get the sources. We'll be building GNOME calculator 3.30.0. So once you have the sources, you have to build it and install it to an app there. The app there will be the starting point for creating our app image and will be what the content of the final bundle. First, we're deploying our application binaries and resources. Notice that it's important that things like the desktop file and icons get deployed into the app tier. Like this. This desktop file will be used by the app image builder to properly generate the recipe. Now, the second step is to make sure that our application runs. In the case of GNOME calculator, it has a glib schemas that need to be compiled. We're going to do that, and we're going to try our application. Okay. Now it's running. Let me share it again. Okay. We have the calculator application running. Once we have the application running in our development system, we proceed to generate the recipe using app image builder. If we use some environment variable like to run our application, we will have to use it also with app image builder as it runs the application in order to resolve dependencies. We use the generate feature of app image builder. This will look for our desktop entry and we'll read the application information from it, like the ID, application ID, name, icon, version, the main executable, and arguments that will require. Also, it will ask us for the architecture of the final binary. The application is now running. It is important that when the application is running, you use almost and try almost every feature of the application. Why? This application is being run with strace and LD debug libs in order to discover which binaries and libraries and resources are being loaded at runtime. So if you use, you should like try almost every plugin and feature in order for them to be loaded in memory and to be discovered by the generate tool. In this case, the calculator application is quite simple, so it's fine to do it so far. Okay, now let's go back to the terminal and add a recipe an AppImage builder file was created. Let's take a look at it. In this file, we will find all the application information that we were prompted for, the runtime configuration. These are the library paths that will be used by our application, and will be also information about the apt sources configured in our system. In this case, for the final recipe, I will not need nor Docker, no VS Code. Also, I will not need Steam nor Node. It is important that for the final recipe, you remove the allow unauthenticated sources, as this might be like a source of bad software get into your final bundle. I'm leaving you. Instead, you should like add something like TURL and put there the URLs of the different repositories. So below you will find a list of the dependencies that AppImage Builder generate found. Basically, is the conf. As I'm running KDE Neon, it says that KDE config GDK style is a dependency. If you build this package in normally, probably this will not be part of your recipe, and you can like safely remove it. In this case, I'm leaving it as it pulls other dependencies like libgdk3, and everything gets pulled from there. So I'm leaving it there for the moment. The exclude list can be used like to opt out some packages that you might not want in your final bundle. Also the files, and this part is one of the most interesting. AppImage Builder will run the final bundle in different environments. In this case, it will run it on Fedora, Debian, Arch, CentOS, and Ubuntu. This will give you like a certainty that our final bundle will run in those target systems. It is super important like to try as much as you possible, because no Linux distribution change a lot. Library names might change, a lot of things might change from one distribution to another, so always test. Okay, so far this recipe should be good to build. So I'm saving it and running AppImage build. Okay, the first thing that AppImage Builder will do is like update the apt sources, and then it will download all the required packages and will deploy them into the app tier, as you might see. Okay, let's give it some time. After all the binaries are deployed, it configures the application runtime. This is basically, it sets a custom interpreter path for every binary in the bundle. This path will be used to be able to switch at runtime which glibc and LD Linux will be used. Also, it sets configuration for Qt as we are building in a KDE-based environment. Some Qt might have slipped into the bundle. Sets the JDK configuration and other things. Now it is running the application in Fedora. I will show you. Okay. This is the application running on a Docker container of Fedora. I'm going now. It will run it on the next one. This is Debian. You might see that the icons and the fonts may change from one system to other as it adapts to the system theme. Now it's Arch. No icon for Arch. Maybe Arch doesn't have that icon in the theme. And CentOS. Okay. Next, and finally Ubuntu. Okay. Now we're sure that our application runs on all our target systems, and the build proceeds to create the final bundle, which would be named Optimus Group. This bundle is ready to be shipped as it is, as you may see. Well, you should not see it too much there. Okay, now you do. Now you do. So this is our final bundle. It is quite big, and now we will see why. If we go into the app there and check the bundle.yml file, we can see which packages ended inside the bundle. In this case, we are bundling a whole icon theme well, how do you say? That probably can be opt out. We are also, actually we are bundling 3 icon themes. This happened because of the apt dependencies. All of them are being pulled inside the bundle. Now you have to manually opt out the things that you consider that can be excluded. To do that, so we're going to use the exclude section. Okay, add with remove a with tab. We're going also to remove icon tone and humanity icon tone. Okay. I probably can remove the whole KF5 stuff on a lot of Qt, but if I remove this one, if I remove this one from the include list, I will not get the dependencies included, so I might need to do something like this. Show okay, icon type, and instead of this depends on a lot of stuff. That's why our bundle is so big. We would only probably need this section of the dependencies and not the whole KF5 stuff. Let's give it a try. Notice that you can do this in order to force a given package version. So those entries are fully passed to apt install. You can also do this in order to enforce a package from a different architecture to be bundled. Just make sure that you add this architecture in your source lines. But in order to make your recipe more versatile or more compatible, we will not enforce in any dependencies. Okay, let's give it another try. it is always a good idea to start fresh when making an app image, because it may affect the execution. The one previous execution of a image builder can affect the next one. So always it's a good idea like to start fresh and to be sure that no things from the previous iteration gets into. No. Okay, my recipe is probably wrong. Okay. Yeah, that's it. Okay. There we go. Now we'll run everything again, and it should opt out the packages with file, and the final bundle should be smaller. Okay, again, it's generating everything. Sorry for the time. It takes a bit of time to build, even a simple application. Now it's running Fedora. All the test cases are being run. I'm getting the okay. Now the application is being built. And we remove a few megabytes. If we can keep doing this process, we can like remove a lot of more like packet, and someone is still pulling libkf5. So we will need like to do this a few times or more, or use like a pure like virtual machine to get like less dependencies pulled by default. But so far this is how App Image Builder creates an app image. As you can see, there is also the sources that were used to create the bundle, so you might like try to reproduce the final bundle. And this is also important, dependencies. What are those dependencies? Those are the libraries that are required to be installed in a system for the bundle to run. Basically, you will find that things like libxcv and libgl, libdl, font config, and others, libcrypt, and others are required. Those are usually in every system, so it's expected to run. This kind of bundle does include much more stuff that traditional bundles. So than traditional bundles. So more sorry. What means that some critical software might slip into the application. So it's recommended for you to recreate the packages and the bundle every time like a security patch it's released. So where you should publish your application? Well, the first place to go is your web or repository at GitHub, GitLab. There's where app image file should live. Also, you can like add them to the existing listings, which are AppImageHub and appimage.github.io. You can like add your software to those listings so they can be reached and found by users. Okay, some reference projects that can be useful, like to check how others are using this tool and what are they doing. The first reference is the Maui builds project. This is super interesting. It's made on GitLab. It produced native EMD64 builds, and it also cross-compiled for ARM64 and builds an Android APKs. So this is one of the most complex but also powerful configuration for if you're having a project to ship it and build it for many different platforms. Also, there is this Mystic video converter tool. Seal is also using App Image Builder. There is a K-stars pull request for building App Image using App Image Builder, and a gcompre recipe also. So about the issues I was talking about, bundling everything, as I said, has an important security issue. Critical software is frozen inside the bundle. That's why you should set up a continuous build environment and recreate bundles every certain time, or every time that a library that is bundled in your package gets a security update. It is using App Image already support Delta updates, so your user will not have to download the whole bundle, only the parts that change it if it's done well. Extra size, yes, your bundle will be a bit bigger. Than it's about 30 megabytes bigger because of glibc is being bundled, which doesn't happens with other tools like Linux deploy. Why are we bundling glibc? Basically, because we are looking for this allows two things. First, portability. Our solution will be able to be used in system with another libc than the one we built the application, and on system with newer libc, thanks to the backward compatibility of glibc. Also because it allows us to build the bundles in newer system. This is not possible for with tools like Linux deploy, where you have to focus on the latest stable release, by example, of Ubuntu or CentOS. And this can become a nightmare if you have if dependencies that are too new or are not compatible, or require tools for building that are not available in those systems. And the final issue is never use untrusted sources for your bundle. Always go with the official repositories to create your bundles. Okay, where you can learn a bit more App Image Builder, we'll check the docs of App Image and the App Image Builder documentation. You can also check for other App Image projects on Awesome App Image. And if you have questions, go to our IRC channel or ask in Stack Overflow. We will gladly answer and be there to support you. Finally, this is my wish list for those people that make desktops, and basically we will love from the App Image project to see thumbnails for App Image, in every file manager. We would like to be able to double click an App Image and it get executed, and it get the execution permission. Of course, you will always warn the user about the implications, and you will not warn them that don't run software that they don't get from a trusted source. Also, the crash reporting, if the application fails to to start to notify the user what went wrong, not just do nothing. Also, we would like to see integration with the system menus, like something like maybe in the file manager, you do right click, add to the menu, and that's it. For doing this, we have libbab image that is already capable of doing all this. It just needs to be integrated. So as the file managers and the system menus and the desktop environments are not our domain as a project, we are not capable of like pushing those changes. The KDE project has already done a lot on this, and that's really great. That you can right now you can in KDE Neon, by example, you will have like icons for thumbnails for your application app images, and you will be able like to double click and just run it. So that was my presentation. Thank you for listening, and please, if you have any questions, feel free.
Thank you so much for your presentation. Yes, there are a few questions in the shared notes. Let's read them out together. The first question is, what does backward and forward compatibility mean? Can I build on OpenSUSE Tumbleweed and run on CentOS 7?
Okay. Right now, App Image Builder is only capable of using apt as package manager, so you will have to run it on Ubuntu or Debian based or another system which also uses apt. So right now you cannot build the app image on OpenSUSE Tumbleweed, but you can build it on Ubuntu or Vulkan. What's the last is? Bionic? I forgot the code name for Ubuntu 2004, but you can build it on Ubuntu 2004 and it will run on previous on all the system without issue at all. And also might run in newer system that came thanks that glibc is being bundled. Yep.
Great. Okay, the next question is, can source code or RPMS also be used as an ingredient instead of deb?
Right now, in the example, I'm building from source code. So you will have like manually built like every ingredient and deploy it into the app tier, as I did with the main application binaries. So yes, but it's not in the way that you will do it with Flatpak, that is part of the recipe. You can also like add let me show you. You can do something like BIM image builder. Okay, I already have it over here. You can like create something. You can add scripts to the recipe, so you will like install all your dependencies or ingredients that are built from source code, make them install them to the app tier, something like this. You can use something like this and get everything installed before like creating your final bundle. So next one.
Okay. The last question that we have here says, instead of excluding the whole icon set, could one trace the application to see which icon files are actually needed?
Okay. This is partially done. Sorry. Not, but it's not like complete yet. the outputs or S-trace can be like checked. Yes, so you can like use something like that. And I guess that's a good issue for our feature request for the project. Yep. Okay.
Awesome. Thank you so much. It looks like that's all the questions we have, but we hope that you can hang around and enjoy the rest of the lineup for today.
Thank you. Yeah, I will say thank you for having me.
Absolutely. Very happy to have you here. On that note, speaking of later, I would just like to let everyone know that in just about an hour and 15 minutes, we will be having the Amalfi Coast virtual tour right here in this room. Please join. It's supposed to be wonderful, and we get to learn all sorts of things about the Amalfi Coast. Again, thank you, Alexis, for sharing your presentation. And I hope to see everyone back here in an hour and 15 for the tour.